Hey everybody, this is Larry. This is Leetcode Biweekly Contest 143. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest. Yeah, we'll see what happens. There's about 40 seconds to go. Yeah, this is the live recording. Each problem will have its own video and explanation and stuff like this. The link is in the description. But yeah, this morning I just woke up. I mean, I guess this happens. I don't know. But yeah, so hopefully I'll do okay. There's only 15 seconds to go. I'm not really going anything. I'm playing Notepad, but I can't find my pencil. So let's see. Like I have a pencil, but not. Oh no, there it is. I have 5 seconds. 4, 3, 2, 1. Go, go, go. My mouse is a little bit weird. I have 2 double problems, possibly. So let's take a look. Oh my god. Okay, let's go, 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 go. T is 10. Okay, looks okay. Have to pause a little bit. Man, I am not awake yet. What's the difference? Difference is look exactly the same, but the example there's a little bit different on the example. Num sub I is 10 to the 5th to 10 to the 9. Okay, so 2 and 3 are kind of the same, but we'll see. Okay, let's actually read the problem first. Given nums to operation k and operation. Select a non-used, add an integer in the range. Okay. I don't know why they changed examples, it's very weird, but okay. 1, 4, 5. Okay. I imagine people already got this actually, so I don't know. Yeah. Okay, so K. Right? Oh, I guess the naive solution is just try every number, right? Yeah, let's do it that way. I don't know. Can you do the smart way, Larry? Yeah, it's fine. We'll do it the dumb way first. something like this, right? No, what am I doing? No. Okay, so we're trying to get all numbers to be I, so then it is just x minus k, x plus k, right? So we're trying. Yeah, okay. Why that doing? Eh. 3 is 15. Oh, 15. Why is it 15? Why is this not, why is 15? So 15, huh? Did I misread this one? Adding 0 to negative, to num sub 1. Return of any limits. Huh? Am I misreading this problem? Maybe. Only 5 people got it right. Well, they're maybe trying to do the harder one. But oh, number of operations. I forgot about number of operations. Okay. So that's different. Okay, I misread this one. Okay. Focus, Larry. Focus. Okay, so that means that you cannot because I'm doing 3 operations, so you only have 1 operation. Okay, that's not great, actually. Okay, I have to rethink this. Okay, how do I do it? We'll use the restroom. Just woke up and not feeling good. Not gonna lie, just woke up. I don't feel great. Had to use the bathroom. Still thinking about this problem. While I was in the bathroom, obviously there's no live portion of that one. Thank you, but 21 people got it, so it's not an easy one either. About Q4. No one's got Q4, so everyone's on Q2. Okay. I mean, I'm thinking somewhat about sliding window, but the answer doesn't have to be. Does the answer have to be one of those numbers? The answer is no, but does it have to be? Wait. I don't know how to do this one. This is so tough. I mean, it's gonna be something like this, maybe, but take no tick. So you can't do anything at that one. What am I doing in this one? I mean, it's up to, right? Because it has to be equal to, I mean, you could just add 0. So, okay. Sliding windows. Yes. Well, okay. So let's say we say x. So there's this, and then it is the number. So this is the number of numbers that would be in the range. How many numbers have to change, right? So okay. So the number of changes is equal to n minus so that's the number of changes. So that means that the same. Okay, no. So the same as f of x. Okay. So it's okay. So actually, same is equal. And so then this is changes is equal to max of this or num operations, and then it is just going to be same plus changes. Okay, that's even more wrong, but and no, it's not. Well, it's so the number of changes is going to be this, not n. It's the other thing that we were doing. Numbers in the range. Okay. 3, which is also still wrong. Oh no, it's min, not max. What am I doing, Larry? 2. Okay. Am I good? I'm just going to audit it. People are slow anyway, so I think I have time to play around. I think this is right though. I mean, maybe I'm doing some silly mistake, but I think this is right. Alright. Okay. Does this work for... This isn't... Oh, no. I was gonna say, does this work for Q3, but I don't think so. Well, definitely not. This is on this range, right? Can we reduce it? We can reduce it by sliding window. Right. The only thing that... So it only changes on... so I'm looking at Q3, but the only thing that changes is that we cannot... num sub I is a lot different, right? So this... so I'm going to... do it on Q2 and change it so that we don't base on this. And I think the thing is that, okay, so num sort difference is equal to, well, maybe something like no. So number, you gotta change it or you don't. I want to say something like, how many people got this one yet? 16? Oops. This is right. I want to say this is right. It's a freebie, I think. All right. Let's see. Q4. How am I doing? Does this even update? Nope. Oh, I have to do that thing. I mean, it doesn't really matter. I should really focus, but I want to look at my. I want to. But I'm also slowing myself down a little bit intentionally so that I could catch my breath. We also know what the thing is anyway, but I'm trying to find the leaderboard link. It's not here apparently, but you do some URL hacking. It's 143, right? So this is the leaderboard. I guess it doesn't update for some reason yet, but that's fine. I did get it. I did submit it, right? Okay. Okay, let's do Q4. No one has gotten it yet. A lot of people has gotten the other two though. I don't even know how it's out there anymore. But okay, let's focus. Oh, this is a different problem, isn't it? Right? This is not just Q1. Alright, let's read it first. And then the T and none of its digits are 0. This is a different problem. Alright, well, a number is 03 if none of its digits are 0. Okay? Return a string representing the smallest 03 number that follows them. Okay. And nums can be some ridiculously big number, so it has to be a number greater than with a T. What's T? T is, wow, T is pretty big. T is a long and still not updated. Well, it's kind of weird actually, but I'm in the right contest, right? Anyway, what was this problem? 8-pointer. The product of this. Product of its digits, okay, is divisible by this big ridiculous number. It's not the sum, it's the product. Okay, so 1, 2, 3, 4 was the product. Just try to do some notepad things. I don't even know how to do this one at all, and the smart people have not done it yet, so I don't know. 1, 2, 3, 4, so then that's just 4 factorial. Right. 24. How do I don't? 24. 256. 256. How many? Can we factorize t? Do we need? Does factorizing t matter? I don't think so. It's just a multiple of t, right? So then for 256. With the product of digits, right? So what does that even mean? 256. Is, well, 256 is just 2 to the 16, is it? Oh no, yeah. No, you do want to factorize it. So 2 to the 50. What is this? 10 to the 7 is so high to factor though. Maybe because then now you have 2 to the 16. Why is t so high? 10 to the 7 is what? 10 to the 7 is high. For the square root algorithm with its prime, what happens if it's prime? Oh, it doesn't matter if it's prime. Okay, because every digit is only from 2 to 9, obviously, or 1 to 9. Well, so you can always just add 1. That slip is actually helpful. Okay, so you have 2 to 9s and then just 1, so then you just divide it. Okay, you factorize it by 2. So this is 2 to the 16. Is it 16? I don't know what it is. I mean, doesn't really matter. 32. To the 16 is just 8 plus 8 plus 4. Right? No. 8 times 8. So it's 2 to the second. Well, yeah, okay. So the only choice you have are 2s and 8s to shorten it, and then it's just a next permutation type problem, right? Okay, that makes sense-ish. Okay, that finally updated. Okay, so you make it shorter, same length. You can make it shorter by doing 8s, and then after that is all next permutation basically, right? A lot of digits. And what is the, well, there are a lot of digits, but it's all going to be 1s, focus, because there can be at most 2 to the 32 or whatever it is, even 2 to the 64 or whatever. Okay, 64 is fine. So then yeah, okay, I think it's reasonable. But we have an hour, right? Something like this, an hour and 4 minutes. Okay, so then now we factorize t, right? F is equal to from 0 to 9, okay, and then now for I. T, well, T 2. Okay. Right. So then now, if t is greater than 1, then we return -1. Right. Otherwise, this one was such a hint actually, but I didn't really read this one until now. But okay. And then now it's just all these numbers. Only thing that I have to think about 2's. Okay, so 2, 4, 8, and 3 and 9 are the tricky ones. 3 and 9 is actually maybe okay, but so the shortest we want to do 9's first. How many digits do we want? 2 times 10 to the 5th. So we want something that's either exactly the same digits or more than 1, right? But that's so hard. Because then now you have to decide whether you want 2's or 3's to shrink in the next number. So that is actually a hard part. No one's gotten it yet, so... Oh, someone did get it. I mean, you know, very smart people. So, okay, so I have to choose between 3's and 2's. Can I do anything with DP? Can I do a one number at a time thing? Right? What would a one number at a time thing look like? Okay, so that means that and let's say t is equal to length of nums. Right, so we want to try d, and then if not, then we'll try d plus 1. Okay, so let's try d first, right? So that means that how would that look like? So we try one digit at a time, right? So each digit is either tick or tick a 2. Okay. So there are only 2 things, one digit at a time. So either ticking or, okay, fine. The fewest and then the lowest, right? So okay, fine, maybe. I don't know. Something like this, maybe. This one maybe is always possible if maybe these are 2 different things, because this one we just want to get any number, right? Yeah. This one's something for now. Okay, but this is the number of digits, right? Okay, so then now we have an answer. Can say for I in range of d. I guess this one will, now it'll always be the same length as nums, so we just literally take it one number at a time, right? So okay. Yeah, okay. So for J, oh, and to find the first number that is, okay, yeah, okay, fine. Actually, there's a, so same is equal to true for now. So then now, if num sub okay, no, we want to do a for loop. Okay, so for J, from num sub I, int of num sub I, all the way to 9. If, so we can use this, what does it mean by the, we can use this? If we can use this, then we're good. So then now enter.append J, continue. Otherwise we have to increment, right? Okay, maybe I'll write this a little bit differently. Okay. If we're the same and good of int of nums I, then enter.append nums I, and then we continue, right? Okay, yes. Otherwise, then now we have to try a different number. Well, otherwise we have to try a different number. The two cases, if same, then we have to try it from this number up. If we already did this, if we did none of them, return -1, because that means that it's not possible anymore for some reason. But this should never happen, I think. Well, it should never happen, but well, it could happen, but only once. But yeah, so this would only happen if I is 0. Maybe, I don't know if that's true. But how am I doing in time? And 2 people got it now. Okay, otherwise we already changed it, so then now I guess we don't need to set G because we have this else statement. And continue anyway. This is not a continue, this is a break. Otherwise we can copy and paste this maybe. So then now we start from of 1, not a 0. Again, it has to be all the numbers, otherwise. Okay, and then otherwise we can return something like that, right? I know it doesn't work. I'm just kind of running because we didn't define good. Okay, that's part of the hard problem. Okay, so then now we're trying this number. So this number is good. How many digits do we have left? It's going to be d minus I. So if we try this number and then, okay, let's say we try the first number, right? So d minus I minus 1 maybe. Yeah, so that means that it is, we try the digit with how many left, right? So something like that. I have to finish writing this a little bit. Okay. So okay. Okay, so we've left digits. Oh, we only have 10 digits, right? So, okay. Can we still, so what is the max we can do? The max we can do is just sum of f dot values. Right? Yeah, okay. Longest is equal to this, shortest is equal to so we can, longest we don't need to do this. We don't need to do longest because we can just keep padding with ones. So that's always possible. But the shortest is going to be f of 3 okay, so using f of x right? Okay. It's f of I have to fix some of this actually. Okay, yeah, because this isn't quite right. This isn't quite right actually either, but okay, if x is equal to 4, then we need 2 2s, right? How many people gotten it so far? This is lagged, I guess. I thought they solved everything, but apparently not. Okay, so if x is equal to 4, then it is just and f of 2 is greater than 2, or less than, if less than 2, then we return false, right? It's not great, the code, but yeah, okay. Right. It's definitely yucky. Okay, otherwise this is switch thing, but right, so then now might as well just do it then. We will never check 1. Well, 1 is always fine. I don't I guess here this is weird, but maybe not. Okay, fine. Okay, anyway. Oh, 6 is weird, isn't it? I actually forgot about 6. Oh my, I guess it's just a lot of if statements then. Yeah, I guess it's just a lot of if statements. I was gonna try to do something a little bit funky, but 6, I guess 6 is the only one really, but either way. Okay. Okay, so then now, okay, so those are the 4 statements. So then now we want to say, okay, so longest we can always just keep padding. Shortest we want to say, okay. Short list is tough, isn't it? Because what is the greedy principle here? Greedy principle is that instead of matching 6, you always match the 8s and 9s and you have extras. But is that always true? Because you have 3 2s to 1 8, so then now. Oh, the 6 is a screwy one. Let's say you have 10 2s. No, you always want to do it that way, I think. I could be wrong. We'll have to double check. We'll just get a wrong answer if that's true. And people are good. Okay, fine. Right, so shortest is actually a little bit awkward. What's the number of 3s and 2s? You could DP it. You could DP it. There's only, remember, this only goes up to 60 or 70, right? So, okay. Three, 2, and okay, I can do a lookup then, because everything is only. Okay, I see. So then now it's just 2s and 3s. Right, okay, fine. Okay, so then now, this is gonna be yucky, but whatever. Let's just do it, and I stop trying to get it to look good. Okay, and then now we're trying to get. Right, so then now it would be, the shortest is just equal to f of 5, because it doesn't matter, 7 because it's also prime. Okay, so 2, and then, oh no, 3 is no good, 2, 3, 4, 5, 6, 7, So numbers not divisible by 2 and 3. All right, so then now it's f of 3, right? So then now left is the number of digits, so that means that if the shortest is still shorter than left, we're okay. So okay, so if left is greater than equal to shortest, we are okay, I think. Okay, well, yeah. And then now we have to reword this. Okay. So then now we can either so we have that number 8, 2 is mod 3, left, right, and then it's just left. Otherwise, we do a dp of yeah, okay. That's 8. That's 4. Yeah, just why not? It's cheap. And then a 6. By definition, this should be possible. Otherwise, one of them is 0. Right? Okay, I think we're good on this one, maybe. We have to do the -5 thing. I don't know why I would return 4s here. Copy and paste mistake, maybe. Okay, so I is not equal to 0. Right? Which one is this? 86. So this one. See what we got so far. 1, we have 2. Oh, I want to say if x is equal to 1, we always return true because it doesn't change any leafing. Yeah. Okay, that's still well, but okay. So okay, let's see. I did actually knew that, but numt. No, so t is 1. Why is t 1? Did I messed it up by accident? Oh no, t is 1 because we factorized it. That's actually, I mean, that's fine, but we should probably do a NTSUT just for debugging purposes, if nothing else. Okay, so t is 256, right? We can do f as well. Okay, it's 2 to the 8. I keep saying 16. I guess I just suck at math. 2 to the 10 is 1,000. I think I'm just being dumb. But okay. 1. Okay, that means that. Okay, so we put 1 as the first digit. Okay, we have to. I don't know if we have to, but. And then we try to put 1. Okay, so we try to put 1. 1 is always going to be good. Then we go to 2. So there's bricks, and then we do the next number, right? Yeah, right? Okay, let's just say, well, this is the same, and if this is good, oh, I have to write something like same is equal to not is equal to false in this case. That means that, no, not yet, but here, yeah, I think here either it's right or you have to not do the same anyway. But okay, 1 digit. But why are we not trying ones? So 1. Oh, because it's still the same, so you have to try 2. Okay, is a 2 wrong? Yes. 4 should be right though. Why is 4 wrong? 4. So this is going to be -2, right? And then here, shortest should be 3, right? Yeah. Okay, so 3. We have 2 digits left after this one. We need a. The shortest that we can do is 3, which is this true? This is true actually. So this is actually correct. But then why is the 4 not correct? Do I not increment back? Oh, I don't decrement for all the other numbers. I am dumb. Of X. I mean, that's just wrong anyway. I don't know if this is enough, but well, no, that shouldn't change anything, I don't think yet. But okay. I don't return early, do I? No, okay. Shortest is 3. Yeah, you can't do a 2 there, because then you still have 3 numbers to go. Okay, that makes sense because you have 7 left, 7 2s left. But then the 4 2. Why is this returning false? Why does it not? Going to here? Huh? Huh? Did I look at the framework? It doesn't go here, that's good. Oh, this is wrong because this is an else if. well, if x is in 2, 3, 5, 7. Okay, I am a silly boy. Okay, so we have 1, 4, 8, 8. Oh, because my 1 is always true. Is it always? It's not quite right. 1 is always true. No, I mean, I think we can just remove that one and maybe that should be fine. Basically, skipping 1 is what that does. But over 4. We want 8, right? So, oh, this. Oh yeah, we have to decrement after getting the good part. So okay. Which is this part. Okay. Okay, so that's good. We take away. No, is that good? Wait. Oh, this is now failing here. That's why I don't see it. We try every digit. Okay. I'm on half an hour. Okay, so we try 1 and a 4, and then the last digit's no good. Why? Because you don't decrement, Larry. Oh, because we wrote this function, but then we forgot to actually use it. So tj decrement j. Nope. Okay, so we have Q1 and Q2 maybe? Do I? No, this is, oh no, this is right-ish. Nope, it's not the smallest, that's why it's wrong. Okay, I mean we could debug this, that's fine. It's good. 355, 355. Oh, it has to be, it is exactly the same. How did I get a 1 in there? Because I do a 5. Why is 3 no good? Okay, let's see. Still half an hour. I think I'm okay. I mean, we're the right idea. We'll see if this is good enough for us to get through. 1480 is good. 1, 2, 3 is no good. Why? Did I just do the math wrong? Oh, 50. Oh, is the okay, I think this is the part that I okay, we have to change the function because it is a multiple. Okay, okay, maybe this is a little bit wrong. I would basically my solution is that it has to be exactly 50, but not. Okay, so it doesn't have to be a number here. It could be a smaller number that multiplies to a bigger thing. That's why. So that assumption is wrong. So that means the good function is kind of wrong. We can do this as long as so that's more like a requirement. So it is a more than exact constraints. So none of these are actually false. In fact, none of these are false anymore. Yeah, none of these are false anymore. We can do all these. This could be which is just called right. Yeah, whatever, let's just shorthand it. Okay. Okay. As long as we're still able to get the shortest to be true. Because those are the requirements. Okay, I think this is right. Okay, self-smallest. What does self-smallest mean? That means the first digit is going to be a 1 and you're going to be forced, right? That's basically it, I think, honestly. Yeah, okay, fine. And then same as you go to force, and then just everything else, but I don't want to copy and paste. So maybe I'll do same. Yeah, I think this is good, maybe. I mean, it should be always, the numbers always should be a 1. Yeah, maybe I don't need to write it this way. Maybe this is just return 1 plus this thing, and this is t minus 1 on the old one. Force is 4, and that should be fine. We don't even need nums actually anymore in that case. Okay. Okay, maybe, and then now we have to do how do I force it? Well, just do like Maybe, I don't know if that's actually true. Well, it's good that we test this. So, okay. 02. Try all the numbers. One 106, so it's this one. So we do print out this thing 9999 T F. Do I not increment it back correctly? What? Why is this going to be this thing? 50 is 2 times 5 twice, right? So it's this thing, okay. We try a 9. I guess we never, do we ever return false? I guess this is. What is going on? Why? So we do first number is 9, okay. We have this left. Okay, no, this makes sense now. But then now it is no longer possible because the number is okay. Yeah, actually, because of the multiple thing. So okay, yeah, okay, fine. Maybe that's no longer true. It used to be true, but no longer true because of the multiple thing. Because it doesn't have to be exact. Okay, maybe you're right, Larry. -5. Oh, because I defined this twice, even though I wrote it again. Okay, it's a good thing we tested because that would be a very, very silly mistake. Is that right? 255? That sounds about right. In fact, you can probably do a greedy on it, but I think this is fine as well. Okay, let's remove some print statements, and then I think we're good to give it a go to get the wrong answer, and then we'll figure out the rest later. Okay, still have some. Okay, 1-4. Double check. I don't know that I expect this to be right. Yeah. Ooh, I mean this is silly, Larry. The answer is 588 anyway, so this is wrong. Because this is doing this thing. Well, yeah. I mean, yeah, this was dumb anyway. But so R is equal to this thing. If R is equal to -1, we return -1. Yeah, what am I doing? We have 20 minutes to go. Okay. Put this one in there. This is -1, which is not good actually. Why is 588 no good? Okay, so 320 is going to be this thing. What is 320? 32 times 10, so 64 times 5. So that's 64, this is 5. And then we return -1, why? Oh, because I tried the 0. Wait, do I? Well, yeah, that's what. No, that's not what that means. Like, so the first digit 3. T. So we try 1, 2, 3. Well, it should be a 5 should work. A 5 should work. Okay, 2, 1. Oh, that's. Okay. Oh, and then try one more digit, which I guess doesn't. I don't know. This should still work though. I don't know why it doesn't work. Okay. So here we try a 5. 2 digits left. We have 6. Why is this no good? Oh wait, no. Look at this one. 1 digit left. Okay, so you have this thing. Oh, I tried to put a 1 maybe? What is the first digit? No, the wrong case, Larry. Okay, focus. 5. Shortest is going to be 2, which is true. Yeah, 6, right? Left. So we have 3 digits. What is D? Did I do D wrong? This D is not the same as... Oh, no, it's fine. Okay. D is 2. Why is D 2? Oh. Oh, I was wrong. That one digit is not... The next digit is not always 8. Okay. Okay. Wow, I misread the input. Okay, so that took 5 minutes to debug, which is actually not great. To even look at it, I mean. Okay, so this is wrong, which is fine. But okay, so then what we actually want is okay, so then now we have for okay, we just try every digit, right? So if we try, no, this is no, you want the right, the one with the loop. Okay, I am just being dumb today, but that's fine. That's actually, I mean, that's fine. That one I don't really worry about that much. I just kind of lapsed. Okay, so then now we try the 1. This is gonna be D minus 1, which is what we had. False. If this is true, okay, well, R is equal to this. If R is equal to negative 1, we continue. But this changes to F, I think. So we have to be... Yeah, I think this changes F. Oh, that's fine. We can just redo it. Yeah, okay. Yeah, we can just redo it. Okay, and then we continue. else we return -1. Otherwise this is good, and if this is good, then we can return j plus r. Okay. I thought that the next one would always be. This isn't right yet though. Yeah, I don't think this is right yet, because then now you can, this leaves open for a lot more digits. This is just me doing. Oh, that's so hard though. Okay. This isn't right though. Also copy over that as well. Okay, I think I get it, but I don't think I got it. I mean, I'm gonna submit it, but I think I see a case where I'm wrong. Oh, this is what? Oh, that's why. Okay, I don't need to do it this way. This is south. Not good. I think this fixes it for this one, but south. Oh, so wrong, but oh wait, slightly less wrong, maybe. Maybe. Yeah, I don't think I'm solving this one. This is, there's still one big case I have to figure out how to do. Yeah. Okay. So 5. We want to remove it from the requirement. So we want to do this, and then we decrement J, which we don't have here. And it becomes DP. 458. Is that right? I mean, it's not right, but why? Okay, we try a 4. We still have extra digits, right? Why is the shortest one? Why is this just not printing anything after that? 458. Oh, because it's printing here, but then the good function. Why is that not printing? Oh, maybe it is. Oh yeah, it is. 5. Okay. And then an 8. But there should be 6, right? So we... Oh, we don't... F is equal to a copy of this. Should be 4, right? What? Document J. 4, we document 2, and that's right. Why? Come on, Larry. Is this after document? I guess so. Oh. It's because I'm reusing these things. And this reference, I think, changes with this reference. I'm being sloppy. Okay, back to -1, which is also not great, but okay. So we have this thing, so that's good that that doesn't work. This for 3 digits left, right? D. I can't even get this right, even though D plus 1, right? Yeah. Like I feel like I'm close, and then it's just become DP, which I don't even have time to think about. Just debugging. 5. This is right for 5. Okay, yeah, this is right for 5, but then why is it not right? Well, it just tries to do 5, 5, 5, 8. This F is also different. Oh, I see. Because this is... I got it. Okay. But that's still not good enough, I think, because you could do something like that, and then it returns -1, even though there's clearly an answer. It's just a very big answer. Okay, that means that we can do the shortest. Okay, I see. Maybe we still got this. Yeah. Okay. If shortest is greater than equal to length of, if it's greater than length of nums, then we just return, yeah. Okay, maybe we got this, I don't know. 5's, okay, new f, new f is equal to whatever, 0 times 9, right? We want it greedy for okay, so this 6. Do we want a 6 or a 4 and an 8? We always want a 4 and a 4 and a 9. Okay, so that means that we always want to bias toward the shortest digits. Okay, fine. Yeah. Well, And then while f of 3. Okay, and then now, yeah. Uh, 3 minutes. All right, focus. Maybe. No. Oh, M is here. I have no time. Ran out of time. From 1 to 10. Why would I? Okay. Okay. Is it right? I don't know, but I gotta take out these print statements in case they mess me up. I have about a minute. I have some really small print statements left. I think I have one more, but okay. That's YOLO. Still probably wrong, but I think this is a good try. I feel like we did enough. Okay. I mean, this is so close. We have to do... Oh, so there is a thing where you bias toward getting a 2 instead of... Oh man, this is so hard. I'm gonna upsolve this, but... This was a case that I was worried about. And this is where you do a DP instead, I think. But if I have like 10 more minutes, I should be able to do it. So let's do it then. All right. Yeah. We were so close. How many people got this one anyway? I think we were close, but I mean, I'm fast enough on the first 3 anyway, but still. Yeah, I mean, I did it greedy because I ran out of time, honestly, but I did foresee maybe that this is the case, but I just ran out of time, so I had to do greedy. But that's, yeah, okay. I mean, we're not gonna solve this. Okay, well, now it's done, but, yeah. Yeah, I mean, this thing I only had to get away quickly anyway, but okay. So you want to do a 6 instead of an 8. That is tough. How do you handle this? Because I greedily remove the 8. Is there an equivalent greedy? Can it? I mean, the only question is whether that could be a 2 or not, right? Okay, so this is one way of doing it, but then now, so the other thing is if there can be a 2, right? Yeah, I mean, I think we've done this like another 5 minutes or 10 minutes or whatever. Basically, we just do, right? I mean, just like this good function, really. Yeah, I think I would have gotten it maybe, but yeah. So this is the shortest that we can do, right? So new short is equal to this. Maybe we we take away one of them, and that's really it. Okay, so here maybe we do this as get short, which is just this thing, right? Yeah. Okay, so then now we have right? I mean, we could even just do get shortest of f, right? So then here we can do get short a is equal to this, b is equal to get short of right? Same idea really, but yeah. And then now, no, you need a 6, I think, here. I just didn't even consider 6 really. I think you're forced, maybe. Yep. I don't know if that's true actually, but yeah. I mean, this is still wrong because I have a 7 here instead. So something's a little bit off. What did I had before? Okay. I think the 3 just disappeared here, so something is very wrong on this one. Yeah, so we took a 2. I'm so I mean, yeah. I mean, I'm watching this even now, but that's why. But still, so, okay. So, right? Also, I have to do some things to make sure that this is possible, but I think it's by length. So the minute is wrong. I think maybe this is. I don't know. I'm just so close. But alright. Regroup. The shortest is already going to be right? And now, if length of b is equal to shortest, then we just return b. Otherwise, we just return a. I think that's the biggest thing, right? I'm surprised that. Okay, so this is f on one of them, and this is f on the other. Removing a 2. We have 7 8s, and then you have 1 2 left over, and then we have 1 3 left over. So I think something is very funky here. Like, what is this? This is a 4. This is a 9, right? So you have a 4 9. You want a 4 9 over 3 6 or 6 6. So I think this should be right. I don't know why this is actually returning something funky. But I mean, I'm also just taking my time a little bit. Okay, so it's 113. Why did I? How did I just miss something? Oh, did I not increment the right number? Oh, whoops. I'm just dumb. I just forgot what I was doing, honestly. I think this is actually... So I would have gotten it in like 5 minutes if I focused maybe. Oh, maybe not, because this is weird. Why? Because... you have this number or this number. Let's print A, print B on top of each other so we could kind of see. This is the wrong one, this is the right one. Oh, did I think I just returned the wrong thing. I think... No, B is the one with the short... So then why... They're the same length. Oh, because... No. What? I'm so confused. What is shortest? 12 is the shortest, so maybe my shortest math is just wrong. So maybe there's something wrong with this. What number am I forgetting? 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, I don't know. What? Is my shortest math wrong? Is this not? Oh, well. Five and 7's right? No, that should be right. So is this wrong? Why do I have 12 for this? I have 12 because we have 1735. We don't care about those, so it's 23 and 1. So this should be actually just like 1. 23 and 1 should be 7/8. And 1, 2 and 1, 6, right? So then that's just 7, 8, 9 digits plus 4, right? So what am I calculating? I guess I maybe I was would have been wrong anyway then. Okay, short. That's 8. Is that 8? 7 plus 1 is 8. Yeah. 8 plus 4 is 12. No, this is definitely 13 digits. Am I factoring wrong? No, it's 22, not 21. So it's going to be 7 plus... Yeah, okay. No, that's... Wait, 23... We take a 6? What if we don't take a 6? If we don't take a 6, then we have 2 and 1 left over. So... If 7... No, I mean, this still should be... Did I take a digit off by accident or something? Should be 9, right? Wait. 2 and 1. 2 and 1. Two and 1 should be 2, right? 2 2 and 1 would giving me a 1. Okay, well that is just wrong. So I guess I have some other mistakes here. 2 and 1. Right, so 2, 0, 1, this should be whatever, and then 6 is gonna be 1, 0. So this is 0. Oh, I'm just dumb, am I? This is, I don't even do math here. Oh man, how I'm very good at math. This is what happens. Okay, well, okay. I mean, it's still wrong for some reason, but oh, this is 20%. +1, +1. Oh no, this isn't +2. This is +1 because you only take one digit. Okay, it's still 16 for some reason. 2, 1 is giving me. Oh, I guess I deleted it. Okay. Is this right at least? I don't know how I forgot to adding stuff. So 2, yep, that should be right. Oh man, I don't know how I forgot. Okay, so anyway, so then now we have alright, so I guess we were off by quite a bit. I mean, maybe we should have still gotten it, but still. Okay, short. We think it's 16 here for some reason, but M should be 12 already, which that's a little bit high. Alright, I think I may have went by very fast on this one, so let's take a look on this. Yeah, that's just doing. Is this a max or a min? We want a min, right? Why did I get max here? I don't know what is. I think, well, I definitely rushed this part honestly, but it's not great. Yeah, okay. Wow, I don't know how I okay. Well, I don't know. Okay. I mean, I guess I was just wrong, really. But let's see if this is good enough for us to be right. Hopefully, it's close. Yeah. I mean, I need to do a couple of things, right? So, oh well. 1, 1, 2. Okay. 19 with 2. Oh, okay. So there were even more edge cases, so I was not close at all. But yeah, because then now. Oh, this is just because of. How do I even handle this? Honestly. Well, no. This 2, 1 should have been. This should have been handled. Actually, it's not a special. Well, it's not a special enough case. So it should be handled here. I have a 2, 1. Yeah. No, this one. So then here it's the same, no good. So then now if it's the same, then we go from 2. Right, we try a 2. This is annoying to debug, but we will have to do it. It is what it is. So we definitely had a couple of issues, clearly. 1 and then a 9, which is weird. Oh, because 1 always returns true, because it thinks that 112 is good. So I definitely did some math, or not math, just logical wrong here. Okay. So it thinks that the 1 is good. Can I fix this? And can I? But it's not big enough. That's why this is not good. Do I have to digit DP this? It might be that I don't know how to solve this actually, but I mean I know what the issue is, sorry, but I just assumed that 112 is going to be good, but then now, Oh, because I think I assume same is always good. Okay, so we have the same, and then it goes here, but the same logic has. Okay, so because if they're not the same, then we can do everything else, right? It's true. Or we can just get the smallest. If it is the same, it has to be that prefix or whatever, right? So then that means that in the same, then this good logic has to be a little bit different. But I don't even know. 19s are a problem. I don't know. Like 199, or it doesn't have to be ones, but how do I handle that? Okay, let's say I thought that it is possible, but then it turns out it's not possible. Then what happens? Can we rerun it? Maybe I don't know how to do this one then. How do I? Because I don't know that this only have twice, because I think you can do something like give them 119, so then we can't just like blindly increment. So now it's 120, 1 or whatever, yeah. And if you try to naively put a 2 up there, that's not going to work. And then there's this thing with the multiple, right? So it assumes that you can do it, but it has to be bigger. But the multiple thing is not enabling us to do it. One 9, how do I? Honestly, right now, I'm trying to figure out the two possibilities. One is just that maybe there's an edge case. Maybe this is an edge case that I have not been able to figure out. But alternative is that that maybe there's another algorithm in general, right? Which I have not really. So I was not that close actually. I was very well, but so I don't feel so bad about not getting it now because I actually did not consider this case, and now that I am, I don't know how to necessarily how to do it. Let's see, 1.9. Yeah, I guess the greedy thing doesn't work because it's the multiple. When it wasn't a multiple, then yeah, the multiple really messes it up unless I can solve it for a couple of multiple or something. Like, is it always a multiple of 10? Like, is that good enough? No, because then, like, you could imagine it'd be like, I don't know, like 119 or something like this, and then I don't know. This is a yucky case. Because I don't know that my this is the one that actually challenges what I think about this form. And then what we have like 39, right? Like we have 39, 2. The answer should be, actually I don't know, the answer is whatever, 41, yeah. But here, so there are multiple ways to kind of look at it. Right. So you have to be able to handle that. And you have to handle that like, but you can't try it on everyone. Because if you have like 1919 or something, then now what's the answer here, right? Like 1211 or something? Huh, actually, did not expect that. But that, what was my input even? 1919. Okay, well, let's give it a second, right? I mean, I think this was before I did this shortest thing. So let's say that there is, that means that there always exists a solution of length. Wait, okay. So that means that the shortest is shorter than length. Then that means that the answer is either length or length plus 1. Right, like if we had 9999 for some reason or something. Which is what we did. Because if shortest is too big, well, if shortest is smaller than nums, then it's always possible. What if shortest is equal to nums? Then it's always possible. Well, yeah, it's always possible anyway, but with a 1 prefix, is that right? I guess that's true. If shortest is equal to nums, okay. So then now, for the equal case, we just have to figure. The prefix still is so weird though. Like the 1919 case is a weird case, maybe. Like, I don't know. I'm trying to think whether it's enough to like just roll this over, or do I have to do it like on the earlier digit? Like, is there a case where it's something like this, but it goes to 2000, right? Something like that. 198, or is it always good enough that like, I don't know, honestly. Like, there should be a case where you can force, right? But it's 4 digits. I can't do it though. I mean, but that's because I'm dumb. But okay, so 10, 10, maybe 100. 2255. And I'm wrong here. So this is a case where we cannot just increment this to 1960 or something. Okay, yeah. And you can't really try it for every digit. Because that's already like a tick no tick thing, and it's like really bad. And becomes n square, and it's the number of num digits. Is it though? This isn't O of n, this is O of 1. No, but then you have to follow it through, right? No, I think this is, you could do like a sub-digit DP-ish thing. Because then now, okay, yeah, maybe I could do like a same answer 0, and here, if same is good, then we have same. Do you have to consider 2 solutions the entire time? Maybe. Is that true? Yeah, I think, okay. I thought this could be whatever, but well, I think one thing that we notice is that we have 2, 3, 5, 7, so maybe we can just abuse that. Maybe. I thought, I mean, the greedy, I mean, I didn't really think about DP because I focused on the greedy solution, but yeah, let's actually open it again. I'm going to restart this problem. Only 12 people got it? No. Really? No, I thought I saw a full page. Yeah, okay. 54th. It's okay. Okay, let's say if this is DP, what would look like, kind of similar to this, right? Okay, let's recap this. Yeah, I mean this is basically 2, 3, 5, 7 anyway, so we can do it this way. And then now, okay. What if it's digit DP, right? I'm too tired to kind of start a new thing, but okay, so yeah, I mean, okay, so we just have a digit DP, we have digits left, we have whether the prefix is matched, number of 2s, 3s, 5s, 7s, right? Okay, whatever. Okay, so if we write out digits, I think actually, well, I don't have to go back. I have this thing. Okay, I think this is actually still right. The shortest thing. Okay, let's just copy and paste this part. And then, yeah. Okay, I think this is right, but I could be wrong. Who knows anymore? Okay, so then after that, it is just about if it's exactly the number of digits. So then, okay, so then now then what do we do? Right. Yeah, we return if 2 is then we're good. Wait, how do I do it? No, it's just that if this is possible, right? So maybe you're not supposed to return the thing in the thing, right? And then we do the loop that we did before, I suppose. We just kind of replace it with a DP. Yeah, okay. Yeah, okay. Actually, I guess we can copy and paste this part too. It's just that the good function is different. Right. We move the good part. Or x and left. What is x again? X is the current digit. Which we can do this. And then now Okay, so basically do this, and then now the good function, it's a little bit different. And then we can say it is if it is possible to, instead of having this function, now good is going to be you go to good go of, what was it? Oh, left. Go of left exactly. Prefix is this. See? And let's say P. P. Man, I'm tired. Okay. Right. And then now we basically try to see if this works. Okay, so yeah, I'm just trying to think for the 19 case, right? So then basically we have do I have to, oh, these are the, okay, so 2, 3, 5 and something, and then the prefix and the left. The index of left is weird, but okay, fine. I mean, technically it should be now I instead of left, it's just the index. It's a little bit easier, because then I'm doing double negative otherwise. Well, no, no. The reason why this has to be left is because so that you can do the d+1 thing. Yeah, I mean, it is what it is then. So then now the current index okay, so I'm thinking through the 19 case. So in this case, then this is actually very weird. The way that this is, this has to be if same and this. Yeah. What was my self smallest again? I think I'm too tired for this. I'm sorry, friends. I'm just a little bit tired. Or a lot tired, really, honestly. I try to think about. I mean, I think this idea is still right. Actually, the not necessarily greedy, but just the one digit at a time thing. I think I just didn't think about it in DP because I thought there's a greedy way to do it, but clearly the greedy way is not right. With the 1-9 case, and I'm just trying to think through what the 1-9 case means for me. Because I try a 1. I don't have enough to fill the rest, it seems like. Yeah, okay. Well, okay, whatever. If it's prefix, then we want to see if we can do left -1. Still prefix is true, and then the value, right? So here, yeah, this is so annoying to write. Okay, d is equal to num sub d minus left or something. The get smallest thing we'll have to figure it out how to handle it, but okay. It's like this +1 actually. I'm trying to think through like the extra digit case and how to handle it, but maybe that's just premature. Let's focus on doing it one by one. Okay, so D, right? So then now, I mean, maybe it's just, yeah, I don't know. I have to do an if statement. I think that's what I'm trying to figure out. Right, so D1, then F. Maybe I could do something like, and these are just requirements, so I think these are fine, but I think I have this stupid M function that I had. Oops. And then I can just write something like, what's it called, lookup. One, we just take nothing. Yeah. 2. I could probably write a loop to do this. I am just being really dumb today, maybe. But this is also like not that bad, I guess. But my question is then now, okay, right. Does it have to be strictly bigger than? No, it doesn't have to be. Yeah, okay, so then now, yeah, whatever R is equal to lookup of D, right? And then this is just going to be this minus R sub 0, R sub 1, R sub 2, R sub 3. Make sure that this is at least 0 for the purpose of caching. And I think we're okay here. Okay, right. It's prefix, so if this is good, then we keep going on the prefix. If this is good, then we return true, rather. Okay. Otherwise, then we try a loop, right? So from the prefix digit, okay, I think this is actually okay, conceptually. Okay, and then else we have, well, now we just try from 1 to 10, so it's the same loop, except for it's 1 to 10. Yeah. And then otherwise we return false, right? Maybe this is roughly rightish. I don't know about this one. Let's just skip this part first. The comment also doesn't even work anymore, but that's besides the point. Invalid syntax, is that true? I mean, they tell me that it's true, but oh, what? I mean, yes. I don't know why. I don't know anymore. I could barely keep my eyes open, honestly. Lookup of 1. It's because it's a digit, so. Document not defined, I guess so. I don't even know if I need all this quite like this anymore, but yeah, I don't know. But either way, I guess for now, just keep it. We'll adjust if necessary, right? Okay, I mean, not great. Well, I mean, this one's right. That's kind of okay, I think. But it's a start. We have to start from somewhere. I don't know how to do the extra digits yet. Don't I have more? Oh, the inputs are here. I was like, I have a lot of inputs. Okay, so I mean, we're wrong in a lot of these things, but hopefully we're making some progress. I mean, it's also right in some places, which is good. Well, I think some of these is just the things that are here, so I think that's maybe lying. Yeah, I don't know. I don't know, actually, honestly. Yeah, a lot of these are kind of lying. We have to get it. Well, we have to fix this one first, at least. Yeah. Maybe we can add some like prefix zeros or something, and then kind of play around with it. But okay, yeah. Well, let's fix this part first. 1488, 4444. Is 4 a good answer? Probably, but we have to try a 1. Why is the 1 no good? Yeah, this thing will always annoy me, honestly. But okay, fine. Yeah, I mean, maybe we'll clean it up later, but okay, so, right? So we have the prefix. It's very awkward. Okay, so then here I try a 4. Well, I try a 1. Why doesn't the 1 work on here? Alright, let's just remove all the other ones we have. Okay. Is this even at least right? What's that? 12 or 4 times? I guess this is actually technically right, but a little awkward though. I don't know that we try a 1, so this is a 1. Okay, so we try a 1. I guess this is no good, but yeah. What happens when you try a 1? Nothing changes. Okay, so we do this thing, right? And then here. So it's going to be 3 digits left. True. And then 3 4s and 3. Oh wait, no, not 1 for 256, right? So that's just a lot of 2s. So 1 does nothing, and then let's just try x left pg. Alright, So G is good when it's 4 but not 1. Okay, that's what I thought. Why is this no good? 1, 3. I mean, this only should have whatever, but okay. So when we try a 1, a 2, we have 8 of these. Is that right? That seems right. 2, 1, 0. Am I off by 1? Maybe I'm off by 1. No, I mean maybe. I mean still maybe, but yeah, that was not close at all. Okay. This is hard to read, honestly. That's why I'm like struggling a little bit. But okay, so what do? We record this afterwards, right? So okay, let's actually sandwich this. So 1 we think is false. No, this is a 2. So this is okay. So this is what we think is false. We call 3. Three digits left. Is that right? Maybe this is off by 1. Is why. No, 3 digits left is right. We have 8, right? And so this. We try the second number, which okay, let's actually then if left is 0, if this is wrong, I guess, because if left is 0, then this is still a rounded number, so that's just wrong. Should be left is equal to -1, which is kind of awkward. Left is okay. With left is n, this is going to be -1. So the first digit, no, yeah, this is off by 1. So then when we start at, yeah, okay, I mean it's still wrong, I guess, but I'm surprised it doesn't complain, honestly, but yeah, okay. This 1 is the second digit and the prefix, right? Fine. The second digit is 2. That is actually right. 3, 4. And that is going to return false. What we want it to do is it goes 488, right? So that means that on the loops it goes to, what is it, 1, 2, so then it goes into 3. So it should be should be 3 true. Okay, so start 1, what? it should run this folder, right? So then now it's a 2. So then it tries to 2, and it goes all the way. It should be 1 4, right? So it should go 3. Okay, so it thinks that the 1 is false. So this returns false. This returns false. Where's my good function actually? Oh. This returns false. But it should return true. So then now the next digit should be a 4. So then that means that it should go to this thing, but -2. So that means that it should be, I want to say 3. Why is there only 1 3? Oh no, this one I guess makes sense. No, it doesn't. Unless it returns true, but it returns false. So that means that 1 is not possible, but why is there no for loop on the second digit? Am I doing this wrong? Okay, yeah. So left. Okay. I am really bad today, sorry friends. Left. Prefix. No, the 1 is right, so then that means that left is going to be 3 true, and then after that oh, 3 true, this is true, so then now we try what's it? Left. What's left? 3. So that means that here we should try 2 false things, right? So 2 false, 8 is, I don't know, a digit. So 2, this should be true, right? Because then now you subtract 3 twice. So this should go to 1 false 3, which it doesn't seem to do. The prefix now. 2 4 6 should be 1 4 3. It doesn't seem like we go there though. Oh, this is actually bottom, so am I doing this wrong? No, 8 is 3. Alright, well, let's try to take a look. Alright, what am I putting? So we want to see with, we want to see 2 4. Okay. Two 4. How come we don't see 2 4? So we see. Let's say 2 4 8. Oh no, 2 4 6. But only 1 4 4. Not 1 4 3. Why? Oh, because we just don't print it. No, we print it here. 2 4 6. Okay, let's see the 2 force 8. Where's the 2 force 8? Okay, 2 force 8. We try a 4. Why is the 8 not working? Or is that a different 8? No, maybe 2 4 6, and I choose 2 4. Yeah, no, I don't know why this is not recursing on 8. Oh, this is what happens when you manually do it yourself. I got too used to thinking that the third element is the second, and then I don't know, I even stared at it a little bit. And I kind of got it wrong. Okay, fine. Okay, so maybe this is right now. I mean, I don't know if it's right, but it's more right, is what I wanted to say. Huh. I mean, this is actually surprisingly good, honestly. I'm just missing the one with the extra digits, which I didn't consider, because, well, I just didn't consider it. Alright, so then now how do I do it? Well, can we add a prefix 0? Would that work? Oh, yeah, and then all lookup. I guess it doesn't have any impact, right? It doesn't change the answer, but it can be an answer. We just, yeah, if r is equal to 0, if r is greater than 0, or if d is greater than 0, right? If d is greater than 0, we do this thing, otherwise everything should be good. Okay, maybe. Okay. And now we have 0 things, but we can remove that, right? Yeah. Yeah, this is going to be a little bit awkward now, actually. But we can just strip out the leading zeros. I mean, we can also just strip out all the zeros, but I think leading zeros is good in that, let's make sure that we're not being dumb in other places, maybe. Okay. Wasn't there a case where I have to add 2 zeros? Maybe? Is that a thing? I thought I was so close with this one, but and maybe I was, but I think some of the idea is right, but it's still I'm just trying to get rid of print statements. Hang on. And I'm going to YOLO submit. I mean, I think there is still an edge case about, like, maybe I need 2 zeros but I think maybe the shortest thing handled it for me. I don't know. Like, there may be a variable number of zeros that we have to handle is what I was trying to say. But yeah, let's YOLO submit. I mean, I'm not that confident at all about this one, honestly. But oh, this is just wrong though, so that's good, maybe. Let's see, what 4 times 9 times 5 is 160. So 180 is just way wrong. Why is that so wrong? Why is that so wrong? That is actually wild. Do I handle the multiples correctly? No, I mean, I think I do. And it's not a leading 0 thing. Okay, so we start with a 4. That looks good. Okay, fine. 1. Oh, it can be 0. That's why. D is greater than 0. Oh, then I don't return true. So yeah, we just don't solve this. What are you doing? So, well, it can be if, I mean, there should be no zeros. That's why something is a little bit messed up. But prefix zeros are okay. So that means that yeah. Okay. I want to say that you can change all the zeros to ones, but that's actually, I think that's true actually, right? Maybe for the input, because you cannot have zeros in the input, but then now you sort in a different order, so I don't think you can just replace zeros with ones, but that means that you can. What did I do before? Oh, before I just try every number, right? So I mean, what did I do before this? If it was 0, maybe I was just wrong still. Huh. Let's look at my old code. That's why I kept it here. Like, do I just mess up somewhere? I guess I have some points there. So I guess I still mess up there. So okay, so I didn't really handle it. But we cannot add a 0. So that means that yeah, so okay. So leading zeros, maybe leading is equal to true. So same as the prefix, and then now what do I do, right? So yeah, if leading, if I is equal, yeah, we can just whatever. If this is equal to 0 and leading, then we're fine. Otherwise, we're no Gucci. How do we know when we're leading? We're leading as soon as we get a number that is not 0, right? So that means that, yeah, this is so annoying. The way that I wrote it, I mean. Okay, so if this is the same and it goes all the way up, so that means there has to be the same. Otherwise, by definition, right? So okay, so yeah. If it's equal to 0, then it's fine. Otherwise, if num sub I is not equal to 0, oh, I mean this is either this. Okay, if this is equal to 0, then if leading, then we're good. And then there's this else, so if it's anything else, we're also good, but we also want to reset the leading 0. Okay, did we fix all the other ones? Maybe. Let's go. I'm a little bit lazy on this one, honestly. One time, did I print out too much stuff? No, I have. Oh no, because I do the strength thing to remove leading zeros because I'm lazy. Oh no, it's not even leading zeros. Well, I use this to remove leading zeros, but okay, that is just silly. Because I do. There's no zeros to be removed here, but yeah, well maybe this one is apparently, but yeah, okay, fine. Left trim or something like this. Is there left trim in Python? I feel like there is, but outstrip. Maybe I should have done that. Outstrip 0. Is 0 a possible answer? I don't think so, right? No, so maybe this is fine. All right, that was a. I mean, this is that. I'm annoyed at that particular one because I actually make that mistake like a couple of times. So it's not like it's the first. Okay. But I think it's because I do this trick though, so I don't know. I don't know if this is. I think maybe we can remove this for a little bit tighter code. We might have to add more zeros, but I don't think this is right now. Just to be clear, because I think there's like this one, you have to add multiple digits in the shortest way. But maybe I can just add enough zeros to handle it. I don't know. Times num times length of num. No, well, the worst is 60, right? So we can maybe just do like times like 64 or something, but whatever. Because it could be just 2's. Can that work? Is that cleaner? Look for this one. Let's give it YOLO submit. It does make things slower, but oh, why is that? Wow, that is a really big input, which I guess is fine, but why would it be that slow though? I guess we just save enough time, that's all. Okay, well, I mean, I guess we had this one. Because basically this is the case of well, it doesn't even have to be, right? Because it could be a multiple, so that's why this is the thing. I guess you can probably brute force the first digit on this one, maybe. I mean, this works anyway, apparently, so yeah. Which is actually very funky. Maybe, I mean, we kind of did this part because I kind of brute forced this. Okay. Yeah, I mean, I think it's a very awkward case analysis, but I think this is fine. Yeah, I mean, I was actually kind of like very close to being right on this stuff, but yeah, I wonder why. I guess it just changes to n times 60, which is already too big as a case. Okay, I could buy that as to why it times out. How long does it take now? Well, 6-7 seconds, which is not great, but I think that there are probably optimizations that we can do, but I don't know. I don't even know what is this answer anyway. It's just a lot of ones. That is weird though. I would imagine all the ones, like, they shouldn't be that long if it's all ones to get a possible answer. Is it timing out on other things? I mean, this particular case, I don't think it times out. But I think on the other one, it was like if I just did this times 60, like why does that time out? Does it time out for this input? I don't think so. I mean, it may be the input that it finished with. Yeah, apparently not. Wait, why does this? Oh no, well, yeah, because now I still have this code, right? So of course it's still not going to time out. It just Oh, still pretty fast. Did I mess something up? Let's try again. I mean, maybe the time's... I mean, I guess at 6.7 seconds, it's just a little bit slower. It's enough to time out, which I guess it's just Leetcode being silly, honestly. I think this is actually fine. Like in a per test case basis, I think this is fine. It's just that, yeah, the aggregate of all the input, it's a little bit slow. But yeah, because if you look at this, it's... Yeah, I mean, this is actually... No, I guess this is a pretty bad input. Because then now I do try 60 times n, and 60 times n is a little bit slow, for sure. I mean, I wish they... I mean, I don't know why they did it this way. I don't know how you can do it without it, per se, but... But... Yeah, I mean, I guess you can maybe, but I don't know. I mean, that's just... Like, I feel like Leetcode is just like a very silly case. Like if they had made n, I don't know, just like a little bit smaller and everything would be fine, right? So yeah. Anyway, that was a very long upsell. Thanks for watching. Yeah, I mean, we still did okay, I guess. But yeah, thanks for watching the entire video. That's all I have for today. Let me know what you think about this problem, this contest, everything in between. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.